All right, let's go. Round two. I have no idea what my question is. I just have leak code pulled up. I'm going to pull the second question I see. Um, Design a system to store and retrieve logs for all of eBay. I'm going to click this. It's 4.5K views. And that's the title of the post, and the comment says, or the body of it says, system design question during an interview at a FANG company. How would you do it? So without reading any of the comments, let's start talking about it. Design a system to store and retrieve for all of eBay. All right, so let's clarify the requirements first, as always. Store and retrieve logs. So what is the actual scope of this question? Do we need? I mean, it could go as far as like actually having daemons running on each server, and pushing logs to this service. I assume that at the very least we're going to have a service that takes in an input of these logs somehow, whether it's like pushed or it polls every now and then, whatever it is. But that's like the input. And as for the output, I would want some more clarification here. I mean, word for word, it just says design a system to store and retrieve logs for all of eBay. So I don't really know what retrieve means. Does it need to be searchable? Do you just need to be able to have those files available to manually grep through? So for the sake, I mean, of course, I don't have anyone to answer my questions. So let's start with the smaller scope and continue to expand on it, right? So let's say there's no daemon or anything. There is an API endpoint where you can post the data to, and you can just post the entire log file. Like each server that is hosting the service will call this API with its entire log file. I can immediately identify some constraints here, such as like file size, time to upload, what happens if it gets interrupted or the server goes down. There's a lot of cases, and we can talk about them, but to keep it focused, and since I have no one to guide where they want this question to go, let's talk about let's just assume a lot of these things that could happen are not yet. So what are the important parts of this system? We said that the input is basically just being able to get the log file, right? Important things that this system should have. It should have backups, as in multiple data stores. It shouldn't just all be in a single data store in I don't know, Portland. That could always be disconnected from, or have a fire and you lose all your logs, right? So we want data replication across a few different networks, areas, data centers. We want it to, I mean, storage is probably going to be one of its big optimizations, right? It's going to be holding, well, actually that depends on how it's going to be queried, right? Is it mostly for long-term cold storage? And let's say this is, they say eBay. I was going to say that, if this is maybe a lawyer firm, there's probably not as much retrieval. But for eBay, for, a company heavily involved with tech, there's going to be new data coming in all the time. And I think old data has a good chance of being revisited. I go to eBay all the time and search completed listings to see what has sold recently and what price it was sold at. So so there's definitely some use case for quick retrieval. we shouldn't assume that it doesn't that like we can put it in cold storage, and that, hundreds of thousands of users at the same time maybe querying old data, at least a month old. Okay, so it's kind of hard with that whiteboard, but like what do we talk about? We had said data duplication, or data what was the term? Let's just call it duplication. Basically, it should be available in multiple data centers. And that one of the things we probably want to optimize for is its storage. However we choose to store it, should be able to store a really large amount of data. I'm going to assume it's perpetual. It's not like a rotating 1 month of logs, but for whatever case, for auditing cases, this needs to be permanent. So the amount of data is really big. And I mean, retrieval is where it really gets interesting. Like how much does it have to index? What are the inputs and the limitations that you can pass in? How do you expect to retrieve this data? Are you expecting to give it a day or time range? And then it can just try to retrieve the logs associated with the logs that fall in this time range. And even then, I mean, we'll probably need to get more in the weeds about how it knows it shouldn't be searching through every single file and seeing the timestamp of every single file, right? We need to be smarter about that, and that's probably one of the first areas that makes sense to expand. But this all comes down to how do you plan on querying it. I'm just kind of pulling off of my experiences. Of course, like the obvious one is keyword, but that's also usually the most expensive search because that's actually going through every single line and searching for a key, like an order ID. We want to reduce the constraints before we get there. So time seems like a very reasonable. So like in the back on these servers, yes, they need a lot of storage, but we also need like an intermediary storage that can help you point to the correct file faster. We can like index these logs so that we can quickly find the data find the files that contain the data we need. So what does that look like? On my computer, it's to help organize some thoughts. What are some of the columns in this table that I could see us storing? For one is a timestamp, and I would actually go a step further and say like start time, end time. So I'm going to write those down: start time, end time. Let's give this table a call. Let's a name. Sorry, let's call it. I'm going to be extra. What is the term? I'm going to be heavy-handed with the name, and let's call it eBay server log table. Maybe a little excessive, but let's be really clear. Since we don't have any context in terms of this interview, maybe it's really obvious in the team, so we can simplify a little bit. But anyway, start time, end time, server, like the actual host that this log came from. And when I say start time, end time, I mean of the actual log data it holds. What may be important is what time it was sent. So let's say like from sent from the server to our log service. Let's call it received time, right? And this would be once the log is fully uploaded onto our service. We will populate this column ourselves. It's not part of the input of the call. Receive time. I guess it kind of depends on. I was gonna say it depends on what like this data looks like, how much further we can index. Like, are eBay's, and I'm sure they are eBay servers distributed across regions? Maybe that's another way we can index and query quicker. So I'll add it in for the sake of it. It's probably like a further down optimization, but like region, server region. What's the big? I mean, time is the time. I mean, I'll be honest. A lot of my searches for logs start with time and a keyword, and that keyword is usually something unique, like an order ID or a customer ID. At the level we're storing these logs, we would not have that type of data. Like, we're not going to have a log per customer or per order, right? I mean, at least I assume. It's going to be everything that was running on that application on that server at the same time, and it's going to be serving multiple customers, right? What else would be good? Let's actually give it a second, like a minute or two of silence. Otherwise, I'm just trying to fill in time. Got start time, end time, server, receive time, server region. I mean, I'm trying to avoid actually opening up these files and doing any sort of indexing on the inside of these files. Maybe, except for like start time, end time. I think let's say this is a very simple. There's only 5 columns. Database for now. Oh, I mean, well, obviously the actual log file name. Wow. The log file name that it goes to, and I mean, just we could probably put together a primary key based off of these columns. But I'm gonna add an index key. Sometimes those just help because you want to be able to just refer to a entry by an ID instead of a set of like start time, end time, and service, server, right? That could be our primary key, but it can be helpful just to have an ID. All right, so I'm sure there might be some more things we add here, like log file name came in pretty late, but we'll come back to it. So how do we use this table, right? When I keep using server in our service, let's say, let's be a little more specific and say, let's call this log service, and the server that's calling us is just like eBay application. So when an eBay application, or let's say it's an eBay server, because not actually the application, like the actual MVC web app that's going to be calling us, it's probably going to be like a daemon or something. And how I imagine it is on an interval, probably like based on a cron job or something similar. Every hour, every 15 minutes, every 24 hours, whatever our risk tolerance of potentially losing this logs are. The daemon will take the file that it will tell. So on the server, on the service, the eBay service, eBay app, it should have, ideally, let's say these logs are going to be written every hour, right? It will cycle to the next hour, so a new hour let's say it's 5 p.m. The 4 p.m. log is done and it's working on 5 p.m. It's already populating a new server log, right? And the daemon will only be working on the previous already completed logs. So it will be taking the 4 p.m. log and making that post request to our service. And I say post, like we don't really have to be following HTTP guidelines, but for the sake of this, that's what I'm going to do. It's going to post this data. And out of the columns we were just talking about, what is it going to pass in? So we have index ID, just to reiterate, we have the index ID, the start time, end time, server / host, received time, server region, log file name. The only few you can't infer from the data, so index ID, received time will be populated on our actual log service, right? And just from the file alone and from the request, we would know the server ID. We would be able to, from the log file, pull the start time and end time, and the file itself with the name. It seems like all it really has to pass in is the server region and the file. That said, in order to populate the start time and end time, I think we can kind of like distribute that job, even though it's a very simple job, grab the first log line and the very last log line of this file. We can distribute that and put that ownership on the ones calling our log service, right? So let's add that as part of our input. In fact, let me write this down here. Input to our, let's call it submit log API. So start time, end time, server region, log file. And from that, we can populate all of the columns in the database we mentioned before. So I guess I'm thinking of this table. I mean, there's no need for it to be relational yet. I'm thinking of it could be MySQL or in DynamoDB, both of which we can pass in parameters. So we don't, like, once we have the start time and end time, querying the logs based with some time constraints is pretty easy. We can leave that up to the database, right? And so let's say let's simplify like vastly and say there are only 3 servers running eBay's main application, that, you know, their website, and all 3 submitted a 4 p.m. log to our log service. And you're saying, and someone wants to query these logs and say, hey, what happened to this order that hit an error? They have an order ID, and they have some time constraints. Let's say they can tell us that it was like, you know, at 4:30. So we know we should have those logs already. So what happens? Our service will query its database. It should get, and based on the time constraints, we can say, because we know it's at 4:30, we can say, oh, from 4:20 to 4:50. That's our time constraints that we want to query. The database query will say, okay, well, we want our start time to be after the start time in our database, if that makes sense. Basically, we know it's going to be somewhere around the middle point of the 4:30 of the 4 o'clock logs, right? So we want to say it must come after the very beginning of our start time logs, and it also must be before the end time of our logs, right? That the start time and the end time need to fit within those constraints. And if we're and yeah, and to be clear, we're not looking for like one single row, right? The end time could be 5 hours later, and we're just trying to find the entire list of all the logs that start at 4 and end at, I said 5 hours, like 9. If that was our search query. And in those 5 hours worth of logs, they would all, like each of them, because we had 3 servers running eBay's application code, we would have 50, we should get 15 results, right? And from these 15 results, at least with what we have designed so far, you would actually have to grep through all of the text, and just do a basic search. But at the least, you were able to eliminate everything outside of your time constraints. Now, and I guess to get a little bit more into the actual response values, that depends on what the requirements are. Maybe you just want like 30 lines of context, 15 lines above, 15 lines after the keyword, after the keyword is found in your logs. So, it's a fairly straightforward string search for those, as designed so far. And of course, there are multiple results. You're not just looking for the first one. So you'll probably return something like a list or an array of each 30 lines long of context around each time the keyword was found. And of course, there's like, these design questions can go on forever. Like pagination. Like how many results should we return at first? What about sorting the results? I think we should actually, in my opinion, focus on improving the actual text search. Like, what can we do better there? Right? Because it's very common to allow searching 30, like a year's worth of data across, I don't know, thousands of servers, maybe tens of thousands, for a keyword. How can we optimize? How can we further optimize, instead of looking through every single server, like n number of servers times k, where k is the number of logs they've produced. So if it's by the hour, then 365 times 24 times n servers, let's say 10,000. I don't even know what that number is. This is a humongous number of log files, right? And this is just cut on time too. It's not cut on actual like size of the logs. These logs could be humongous. So how can we further improve this? How can we kind of cache or index the data that's inside of these? And I think a lot of that depends heavily on like how uniform this data is. If we have hundreds of teams working on the same code base, they're not using the same like library to submit like log data. If it's all like freeform, then there's not much we can do. But if there is a logging framework that says, make sure you pass in the customer ID if available. Customers can always browse anonymously, right, without signing in. Make sure to always, pass in the IP address. Make sure to always pass in the order ID if applicable. Then we have something we can work with, right? We can, of course, pros and cons is how expensive is maintaining and keeping the service, like the compute level, the data storage, versus how quickly we need this data. but we kind of have like an L1 cache with our existing table, the what I call it, eBay server log table. And we can kind of further do an L2 cache and say if we know something about this data, let's index it. So using the same examples as before, I'm going to say like customer ID is a very interesting thing to index off of. Order ID. Here it really just depends on what data you're interested in. Like if you're a heavily design-oriented company, it could be like what browser are you using. But I'm trying to think of eBay's eBay specifically. I'm sure they've got like types, like there's buy it now versus an auction, right? So I'm really just putting these as examples, but let's call it listing type. Listing type could be another column. And basically every time we receive one of these log requests, our submit log API we called it, we can pre-process the log. We can say, hey, going through all the data, customer ID was found in this log. Like this is a known, not even this is a known customer, but just that there's just a link from the customer ID to the log they showed up in. So I'm going to say, so this could be relational. Here we could have a key, a foreign key to the eBay server log table with the index ID, right? So I'm going to say foreign key eBay server log table index ID. And so here, then we're able to, for all the customers that appear in each log, they'll have an entry in this table. And I know, like this table's gonna be quite large. But the benefit of it is, say you know, like as part of your input on your web interface or something to query your logs, let's say you know the customer ID and you're not searching it as like a random keyword, but you have a field and you're saying, hey, I definitely know customer ID and here's what it is. We can first query this table and say customer ID, which logs do they appear in? And then, I mean, that alone could be a result. Could be based off of that, we get the rows in our, I want to call it like L2 cache, but like a key data table. Key data appearance table, right? And this is when like very, very key data appears and it's linked to a specific log. We don't actually, oh yeah, no, I was going to say that we don't need a reference to the eBay server log table, the first table we said. And it's true for the use case I just said, where we didn't give time constraints, we don't. But they may, I mean, a totally valid use case and totally normal use case would be, say, this customer ID within the last 3 months. So first, we could grab all of the, we query this L2 cache, the key data appearance table, right, with this customer ID. And then it returns, hey, here are all the logs, not like the log, it's the index ID. It's hard to explain this online, isn't it? Here are all of the, maybe I shouldn't have called it index. Like I should have called it log index. ID in the first table. So here are all the log index IDs that contain this customer. And then this is probably already a small set, right? Like in terms of eBay, yeah, people may be browsing it like 8 hours a day, but I mean, like 8 hours a day every single day, they're gonna, maybe I shouldn't have even said that. But this significantly cuts down our data for the majority of users, right? And then just within these rows, let's apply the time constraints, the start time and end time. Then we probably have this quickly allows us to access so once we the log file that we were looking for, log files that we need to then iterate over and create the response from. And we're at 30 minutes already, so I want to at least talk about what we can improve. I think we can definitely improve this L2 cache, this key data appearance table. I'm not super up to date with MySQL, but I know you could union these two tables when you make this query, and probably just do it all in one query. That is, apply the customer ID and also filter by time. That way, in the first place, you wouldn't get here are all the logs in the past 10 years. Here are all the log index IDs in the last 10 years that this customer was in, but right off the start, you'd have from the one query, you'd have a smaller subset. I don't know enough SQL to tell you if that's more or less expensive. I can see it being more, but I know they have a ton of optimizations under the hood, right? So it may be smart enough to know to run it in two instead of it may be smarter than we think, and it can at least be as efficient as if we made two queries. That's one of the optimizations. And we didn't get to go too much into other ways they could query this. I mean, time and keywords are my big ones, like I said. I guess applying a regex is probably, I don't know if I was gonna say it's probably that could be difficult over large amounts of data, right? Regex are trying to match everything. So that's probably something I'd consider an improvement over a 45-minute interview, because we just have to limit the scope to what we can address. Yeah, we're about 35 minutes, so I'm gonna call it the end of the interview.